Alright ladies, this is Dr. Tausman coming to you live from Roanoke once more. I'm going to go over on today's situation the one-factor ANOVA case that we had for the last lecture last time, and just to add some more information to it. I don't know how long this will be and if I'll do a few recordings, but it's just going to be one that's going to be basically due a week from now. So let's start off with a little review situation. And what you want to basically do here is type the notes in so I can see that you understand all the key concepts here. We had from last week the example of a group that was getting no drug, a group that was getting a drug with no drug. Scores were 1, 2, and 3 for memory, you could say. When they got a drug, you could say the scores were 5, 6, and 7. So a statistician would evaluate, does taking the drug cause a significant improvement in memory? And so if that were indeed the question, we'd have what there? One independent variable, it's the condition in two levels, no drug and drug. One dependent variable, that would be memory, or score on a memory test. So if we got that particular data, we'd run the analysis of variance. And if you look at the ANOVA summary table, you want to put some notes on what all those things mean. Do you remember the difference between groups and within groups? Well, if between groups, we have a sum of squares of 24. Hopefully what you remember is you want that number to be large. That number reflects the treatment effect, the difference between the two means, the 2 and the 6. So you want that number to be large. The sum of squares within groups reflects the spread of scores within each one of these two groups. So the 1, 2, 3, and the 5, 6, 7, the sums of squares in each one of those is of course 2. Because 3 consecutive numbers, the sums of squares are always 2. So if we go through the motions here, to get the variance between groups, you take the sums of squares between groups, 24. You have two groups, so 1 degree of freedom, so the variance, or mean square, is 24. For the variance within groups, the sums of squares within groups is 4. You have 2 degrees of freedom in one group, 2 in the other, so 4 degrees of freedom there, and then the variance within group is 1. F-score of 24 and probability 0.007. So after watching all these James Bond films over the weekend, that probability is less than 0.05, so that is statistically significant. So you should be able to write out that F, parentheses 1, 4, equals 24, and then P equals 0.007, statistically significant, real-world conclusion, the drug improves memory. I hope you've got that down. That's the first part of things. Let's move on to kind of the second situation here. Example 2. No drug, 0, 2, and 4, and having the drug 4, 6, and 8. Now if you do the statistics on that one, notice that the sums of squares between groups there is the same. It's 24. Can you figure out why it's the same? Well, the answer to that is, what's the mean of the first group? It's 2. What's the mean of the second group? It's 6, just like it was in the example before. So the sums of squares there is 24. That's good. 1 degree of freedom. Variance is 24. So that's a good thing. But notice now the sums of squares within group. Now instead of 1, 2, 3, and 5, 6, 7, it's 0, 2, 4, 4, 6, 8. There's more spread. If you have 0, 2, 4, 4, 6, 8, the sums of squares within each of those groups is 8. So the sums of squares, which is error, for the within group is 16 degrees of freedom for. F, or variance, is now equal to 4, and then you get an F of 6. Sig is 0.07, and that's considered marginally significant because there's so much more spread within each group. So hopefully you remember that, and then finally, if you did a t-test on this, you get a t-score of 2.449. T squared equals F. Remember, with the ANOVA, we square everything. So t-score 2.449 would be the same thing. But remember, for an ANOVA, you can have more than 2 levels, more than 1 independent variable, so it's a more general type of statistic. Hope all of this makes sense. Write your notes here showing that you understand all these ideas, and then we can move on to the next section. Thanks. Bye-bye.